Alrighty folks, we are going to be doing a brief review of all the exponent laws that you should remember from last year, but you most likely don't. But really quickly, let's kind of go through all of them. We'll start with multiplying and dividing powers and move on from there. So let's first of all look at multiplying and dividing powers. And keep in mind that x squared times x to the power 3 really just means, well, x squared is x times x times x cubed. In other words, x times x times x. And so you get a total of 5 x's multiplied together there. So the exponent law then is when you're multiplying powers, you add exponents. So if you remember that from last year, maybe you can remember what we do for dividing powers. I'll give you a guess. If you said subtract exponents, you're correct. When you divide powers, you subtract exponents, and the reason why is because if you write out, look at this expanded example here, a divided by a is 1, a divided by a is 1, and a divided by a is 1 there. You're just left with 2 a's on top, so I get a to the power of 2. So you subtract exponents. That's that exponent law. You may need to write these down because they're going to be pretty important and you're supposed to know them. Okay, well, what about a power of a power? In other words, we raise a power to an exponent. What do we do in this case? Do you know the answer? Well, the way if I expand this out here, that just means m cubed times m cubed times m cubed. And we know that we're multiplying powers. We just add up all those exponents. So the answer would be m to the power of 9. In other words, the shortcut is we just multiplied exponents. Don't add the exponents, we multiply them. And there's that exponent law written out for you. How about this one where I have two powers multiplied with each other inside the set of brackets and then an exponent outside the brackets? Do you know what this is the same as doing? Well, there it is expanded, and I can rearrange this because multiplication can happen in any order. So it can look like that, which if we just add up all the exponents, you get s to the power 4 times t to the power 6. In other words, I basically just multiplied these two exponents by 2. Okay, so there's that exponent law written out for you right here. And then we have just two, well, there's one that looks almost the same thing as that, but with division, but same idea. And that's if you have a quotient of two powers, and the same thing applies. That 3 on the outside, that exponent, applies to both the numerator and the denominator. So the result is x to the power of 6 divided by y to the power of 3, and I can't do anything with it because they are not the same variable. That's as far as I can go simplifying it wise. Okay? Anyways, there's that one there written out for you, which leaves us with one last one, my favorite and your favorite too. Here it is. This is the easiest one, right? Do you know the answer? It's just 1. Why? Because anything raised to the power of 0 is just 1, so long as you're not using 0 as your base. Okay? So there is a brief review of all the exponent laws you learned back in grade 9 in 3.5 minutes. Well, let's look at one more that you're going to need for tomorrow's class. Okay, well, let's look at this one here. Now, this is just a division of powers, so you could just do the same thing we did before, whereas x divided by, or sorry, x to the power 2 divided by x to the power 3, we're going to subtract the exponents, which gives you the answer of x to the power of negative 1. But what does a negative 1 mean? Well, let's go back and expand this out instead. And this is actually what it means. X times x divided by x times x times x. Same thing as last time. Let's just kind of cancel out those two x's there and these two x's there. And what am I left with but 1 over x? In other words, x to the power of negative 1 means 1 divided by x. Okay, in other words, it just means take the reciprocal. So let's look at some examples of that and see what we can come up with. Okay, well, first of all the same exponent laws apply to negative exponents as they do to positive ones. So I'm multiplying powers. I'm still just going to add these exponents together, and I get x to the power of 1, because negative 3 plus 4 is 1. What would you get for this one here? If you multiply the powers together, you get x to the power of negative 6. But what does that negative 6 mean? Do I invert it 6 times? No, what it actually means is this. Let's break this up into two separate powers, a power of a power, if you will, like that, okay? And I just take out the negative 1 like that, just to say that this x to the power of negative 6 is the same as saying x to the power of 6 to the power of negative 1. If you did the power of power things, you would multiply the exponents and get back to that. But we don't want to do that. So what does this mean? This means 1 over x to the power of 6. Okay? And so that would be how you could express that. Okay, what about fractions? Well, again, same thing, same exponent laws we've been working with. Multiply top and bottom exponents by negative 5, and that'll get you the answer, which is that. Okay, but what if all we're going to do to figure this out, though, is we're just going to make this a power of a power and take out that negative 1. You can almost just not do that if you wanted to at the very beginning. In other words, have something like this. In other words, just multiply the insides by the 5 instead of the negative 5 and leave the negative 1 out front like that. And all this means then is the 1 divided by that. Now, with fractions, that's a little different. Let's just look at a different example for just a second here. So if you're dividing by a fraction, like 1 over a fraction, remember that dividing by a fraction is the same as multiplying by the reciprocal. And so the answer you would get here would just be 5 over 4. And that's all we're doing. We're always just taking the reciprocal. So the negative 1 exponent doesn't just mean 1 over it. It just means take the reciprocal. Okay, and that's what we're going to do to look at the previous question we just finished looking at here. Let's go back to that question then. So there's the answer that we were left with. And then the negative 1 exponent just means take the reciprocal. So instead of x to the power of 10 over y to the power of 5, it just means y to the power of 5 over x to the power of 10. So in other words, you just flip it. The negative 1 exponent just means flip it. Okay? So I'm going to leave you with one example that I'd like you to try, and you can bring this one with you to homework or to class tomorrow, and we'll see that it got done. So try this one. See if you can figure that out. Write it without any negative exponents. So simplify it and get it so there are no negative exponents like we did with the last one, and then we'll do some more of this tomorrow. Okay, see you then.